Welcome to FI. This has been a long time coming. We tried to run this BA5 twice last year to no avail. We ended up having a webinar last year which was pretty well received by not only Southlanders but also further up country, and that was the beauty of the webinar. We managed to capture the whole country as opposed to just Southland, but there's nothing like a face-to-face. So this year we were still really wanted to do face-to-face business after 5, and we tried to do it obviously at the start of the month, and we ended up sort of pulling the pin on that. We felt that we wanted everybody to be here and be able to relax and not have to social distance and have a drink and not have to have individual food parcels and things like that. So hence our decision to delay this until now. So yeah, I just wanted to start off with a few thank yous. Firstly to the Chamber for the continued support, and including tonight. But you know, if we ever need anything, the Chamber are always there and are always willing and just want to know what they can do to help. So thanks very much for that. Just a couple of other people that I want to mention. Jim Collins from Complete 3D. So Jim has been responsible for commissioning these machines. So we've got 3 machines running tonight. We've got a small one, and we've got Bill in the far corner, and we've got the new one which we're sort of going to do a bit of a reveal on. So we've got 3 machines running, and Jim has played a part in all that. So yeah, appreciate all the help and everything we can do for FI, Jim. Kieran McLeod from SOREC, Southland and Otago Regional Engineering Collective. So we've had a lot of support, and we give a lot of support to SOREC, and that crosses through the engineering sector, but it's a lot broader than that as well. So just one last thank you, and that's to the FI Innovations team. Today has been a big day, just sort of getting ready for tonight, and the team have done a fantastic job of sort of getting ready for this. So I really appreciate that. But just in general, the last few years have been difficult, you know, and that whole roller coaster of emotions and that up and down. But when those times have been down, the team has rallied and we've sort of pulled through. And now we find ourselves in a really great space with a great team. So thank you to the team. So I once was told, you know, when I first got into the business that, you know, to stick with what you're good at and, you know, stick to your knitting, you know, just do one thing and do it really well. That didn't really work for us. Because what we found, it was busy and then it was slow, and we couldn't get that line straight enough. So what we did at that point is we diversified, and diversity has been extremely good for FI and helping us sort of flatten out that line. And so the first thing that we did was industrial flooring. So we've been doing that for a very long time now. But the flooring that you see throughout here, the green room and the design room, and in here, that's all put down by the FI team. So we've always had the fiberglass side, and then the flooring side come on, and then the other bit of diversity that we did was boat building or traditional boat building, if you like, and wooden boats and things like that, which is a very art, and it's actually a dying art. So we're lucky that we've got 2 qualified shipwrights on the team. So, and then probably about 5 years ago now, I started looking into 3D printing and how could 3D printing help what we do, you know, because we make stuff, and I was like, you know, how can we incorporate 3D printing into that? So we bought a very cheap 3D printer that, you know, one of the ones that you can sort of buy from warehouse stationery. That type of thing. Actually, we've got that whole printer that we bought. It's actually set up down on the end in our packing room down there. So when you get a chance, have a look at that. But that's what we classify as 3D printing. You know, you've got a hot glue gun, or basically a hot glue gun and a nozzle, and that moves around and it builds the part one layer at a time. With what we've got and with what we've done with these machines, it's more aligned to additive manufacturing. So it's production and it's end use. It's building lots of parts at once. So we kind of like to have that distinction between 3D printing and additive manufacturing. So going back to how this came about, 5 years ago we bought that, and then we had been keeping an eye on the technology over the time, and we were like, you know, what can we do here, you know? And so we identified select laser sintering build as being a technology that we wanted to take on. It wasn't that it just wasn't that easy, because, you know, we made some inquiries and they said, you know, how much money have you got, and type thing, and it was very hard to get across the line, you know, because the machines they're a lot of money, and it was very difficult to get into the industry, and that's why there's not a lot of machines, you know, in New Zealand. So what we've got here is we've got two of the largest machines in New Zealand, and that hasn't come easy. I think with Bill and this part, I won't touch on this too much because Derek's going to do it in a minute, but this room here is part of Bill, and this is a new machine itself, and with the scanner and all the infrastructure that we had to do to put in, we've got close to a couple of $1 million worth of investment back into the business. So it has been hard to get that, you know, to get that support from different people and also the bank. So when we went to get this machine here, the phone call with the bank at the time, it was an interesting phone call, and we had a few laughs. But in the end, we managed to get it across the line. So Bill came along started 2020, and we had our big launch plan. We were going to launch it to New Zealand. You know, it was going to be amazing, going to be fantastic. That got hijacked. Spent lots of money, had this big rollout plan, and we had the business case, and we had everything, and that all just went to, you know, we couldn't even launch it. You know, we couldn't even do anything. So that was tough. You know, trying to launch that into the market. But in the end, what we found is that, you know, after we come out of lockdown, and a few months after that, companies started to find out what we were doing down here in Invercargill, and so we started getting these companies jump on board. You know, aerospace companies, and, you know, healthcare companies, and communications companies. So we started getting all these companies that were jumping on board and with what we were doing, and that was a pretty cool feeling for everybody, knowing that, you know, a company from Invercargill can actually be having an association with all these companies that do really cool things themselves, and so, you know, sending parts to them in the North Island and Auckland, and so that was a really, really cool feeling. We were supplying parts to one of the America's Cup syndicates. Unfortunately, it wasn't Team New Zealand, but yeah. Yeah, exactly. Yeah. But that was just good to have an association with a team, you know, and maybe next time it will be Team New Zealand, but that was pretty cool as well. So sending parts up there for them to use on their boats, that was pretty cool. 2021 came along, and what I was saying before about, you know, the whole, because we could have retracted into our shell. You know, everybody was sort of saying, like, this isn't going to last forever. This, you know, we're all busy and things like that, you know. And so we did have two options at that point: sort of retract a little bit and just focus on what we're sort of doing, or we buy another machine, and we really get this party started. And so that's what we ended up doing. We ended up doing that, and so that was really exciting. And as I say, both of these machines are the largest in New Zealand. So if people want another option for this quality and this size, they go to Australia. So that's pretty cool to have two large machines like this in New Zealand. I'm just about done, so I'm very close. But on that back wall, we've got there's a Fire Innovations sign there, and underneath that, there's some parts on that table there, and all those parts are not printed from us. They are printed from Rogan Cars up Canterbury Way, and they make like $1 million race cars, and they do a lot in the metal printing space, and they've also got a full engine block that they've printed there as well. Now, they've been kind enough to lend us all those parts just so we could have on show for you tonight. But take a look at those parts as well, just from a metal printing space. So when it comes to polymers, that's where we're playing, and we want to be the number one in Australasia for polymers. When it comes to metal, that's a different sort of space that there are a few playing in. But we just thought that we'd have them here tonight, just so you can have a look at what additively manufactured metal parts look like. So I'm going to pass it on to Derek now, just to talk a little bit more about the machines and about the technology itself. And yeah.
G'day everyone, so I'm Gareth Manson, I'm the Advanced Manufacturing Manager here at PHI. Firstly, we're very, very proud to be able to do this. We've just touched on the history of getting to this point. So to have everyone here and for us to be able to show off what we're doing, it's a very, very proud moment for us. So, and on that, I just want to congratulate Gaz and Mel. To do what's happened here, it takes special people, it takes some pretty ballsy decisions, and it takes some, not just decisions, but actions as well. So, yeah, well done, because yeah, this is a hell of an achievement. And likewise, the team here as well. So, this was empty 12 months ago, basically. So, the rate of change around here has been quite monumental. So, to have a team that can handle that, roll with it, and I don't know that I've heard a steering word in the 12 months. So, it's a pretty special team here. So, yeah, well, if he was steering words, I didn't hear them anyway. So I don't want to get too dry on the whole thing. We can get bogged down into technical this and that, the next thing, but I'll try to keep it up a wee bit. But any questions, just sing out. There's no stupid questions. But the first thing, so we're talking a lot about additive. So what is additive? And we said before, 3D printing, that's one term for it. All you need to know is that either additive is, simplify the word, add. So you're starting with a chamber that's got nothing in it, and you're adding material to it. So each one of these machines that we're going to talk about, in one way or another, will start with nothing, and layer by layer, they're all driven by layer fabrication, you're going to add to it. Ordinary machining or casting or something like that, or not casting, but machining and all that, you'll start with a block and you machine away, so that's subtractive. What we're doing here is additive, so that's where the term comes from. It's like a good analogy. I don't know if you've ever seen the WOS jigs, who knows the WOS jig puzzle I'm talking about? Yeah, so it's all just layers and you build it up. It's exactly, but that's what is happening here. So the big question is, well, why do you do it? Why do you bother? There's injection moulding, there's castings, there's extrusion, there's fabrication, there's all these manufacturing processes. So why are we bothering going to all this effort? There's a few wee tricks up our sleeve that make this process very attractive to the manufacturing world. One of the first ones is the complexity of the parts that we can do is very, very high. So if you imagine you take something that's machined, you start with a block. Every machining operation costs you money. Okay. When we're building parts on here, we don't care if it's a simple cylinder, or we don't care if it's a foot-on lattice structure, and it's pretty much the same to us. So we've got this advantage of having very, very complex geometries for pretty much the same cost regardless. Because of the way the parts are held in the machines, we don't need to worry about tooling getting in. We don't have to worry about releasing from molds. We don't have to worry about holding things in vices and stuff like that. So we're free to generate whatever geometry we choose. And that's why we start talking about medical that deal with organic shapes a lot. Fabricating these sorts of shapes, piece of piss. Right? So it's some inherent properties that make it very, very advantageous. Likewise, there's a term that we called digital inventory. So that means everything that it's a little bit of an Achilles heel, that everything that we need to put through these machines, we have to have a 3D file first. So that's normally easy. Like these days, we're being supplied those very easily, or we can use things like 3D scanning or whatever to achieve that. But it's a digital file. So what it means is that when we talk about manufacturing, as a supply chain thing, and with COVID being what it was, it's sort of brought it to a head as well. It means that on the server, you're basically keeping your parts on there, and you're only printing as you need them, as your forecast sales or whatever are going up and down and all that. So rather than with injection molding, you need to run off 10,000 parts or something for it to be economic. We don't give a shit. We'll just run 5 parts one month, and maybe it's 1,200 the next. It's just click a button. You can do the same for machining and other things, but this is particularly tailored towards digital inventory. The other advantage of that is then we had a case for a manufacturer, we did 1,600 parts for them, and they broke it up into 2 batches. So the first batch went out, and they were able to receive that batch, they could put it out to the market, and then they could come back, and then they could tweak, and they could change, and they could just do all these subtle little differences, whereas if you're tooled up, that would be a major problem. So that flexibility of the design is another major one, which makes it a very, very good tool, especially in New Zealand when we're talking about lower volumes, high value items, and it's sort of really bridging that gap. There's an argument that 3D printing once upon a time was going to replace everything, and again, it's just a load of shit. What actually happens here is, so injection molding, for instance, is very, very good at making polymer parts, and it's going to pump out a million of them, in a week. That's cool. Then you've got the other end where you want to do 1 or 2. You've got this gap in the middle. We've got this sort of area where it's too expensive to do tooling. You only actually need so many, and it's a bit of an area that was actually never touched. So what's happening is this is enabling that space to exist. So we're not taking work off anyone. We're actually enabling new types of projects to exist in a very agile and fast way. So so that's sort of why you do it. And as a market internationally, so obviously New Zealand, just being New Zealand, we lag a wee bit, but it's on this massive growth trajectory at the moment. So 2019, it depends on, quite frankly, which report you've read at the time, but we're looking at about $8.5 billion US market. So going out to 2027, projected to get up to 36 billion. So it's just really taking off, and the reason for that is there's a lot of, it's just a maturity of markets and the accessibility of CAD files and everything like we're talking about. Everyone get their head around it, but it's definitely going this way. It's also because of the popularity of some of the markets that we work in, especially the likes of aerospace and medical, were the 2 main markets that are driving this. As those markets get more popular, you don't have to think too far out of New Zealand with aerospace to know some of those companies that are driving that. And it's, so that being on the back of those sort of markets is pretty important as well. So that's sort of why we do it. What I'm going to do now is just real quickly, just touch on each technology. I'm going to touch on the first 2 technologies, the first being our figure 4. I'll just talk to you just very quickly about what each one is, why we use it, again, why it exists, and then we'll go to a demonstration. We're actually going to take the build out of the SLS. But for a start, this is a highly capable machine. So we've only got a small build chamber in the grand scheme of things. But what we've got is we've got a layer thickness that we can go down to 10 microns. So all you need to know about that is that it's bloody small, right? So that means that the parts that we can do, and you'll see examples of them here, really, really fine detail. And so you're really rivaling the detail that we're getting out of tooling and what have you. A very, very fast build rate. So we love this machine. It's a bit of a get out of jail card sometimes when people need parts same day or next day. You can sort of push some parts out pretty quickly. So the part that's in here at the moment is actually the same group part that you'll get later on. So it's going to take 2 hours to print on its own. that is fast, take my word for it. I did actually slow it down just because tonight's a bit longer than that. I did. So it was actually going to be an hour of print, but I actually stretched it out a wee bit for your benefit. Yeah, so this has materials that are in use, functional. So when we print things, they're going into the real world, they're being used. This isn't prototyping, this isn't just testing, this is functional manufacturing. But yeah, it's a very unassuming little machine. But yeah, awesome, and we love it. So yeah, take a chance later on just to have a look at some of the parts. But yeah, fast, small, detail. So we need to know about that one. So what we've got here is what we call an SLS machine, which is selective laser sintering. The clues in the title, what it means is that a laser selectively sinters areas. So what happens is we've got you'll see like a very fine powder. It's a nylon PA12, which is basically strong engineering plastic. And what happens in this chamber, we'll talk about the layering process again. So this machine's sort of, the bill's climbing up out of it. In this one, which is very hard to see, the bill actually sinks down into it. So what happens is, if you imagine, because we're doing layers, we've got the cross section, the powder gets laid across, the laser comes through and draws all those cross sections, the table drops down, another layer of powder, and it just repeats that over and over again. So you end up with what you're about to see is a big cube of powder, right? Within that, and just a wee hint, there's going to be some questions, Cheryl, we're going to chuck on it soon. There's going to be some wee prizes as well. So in this cube here, pay attention. There's about to be a question. We'll see how bright you are. There is parts that are suspended within that cape. The beauty of this machine is that we don't need any support structures or what have you. And yeah, so they're all in there. So what Marcus is going to do is take that build out, put it on the NQC, and he'll start to extract the parts. So typically a build about that size is about 40 odd hours, which sounds a lot, but we'll talk about part numbers and all that, and we'll talk about per part speed, and we'll start to see that it's actually a very fast manufacturing process. So, first question, how many parts are in that cake? 40? Wrong. 400? Wrong. 1,000? Wrong.
Yeah.
What did I say? You're really tiny.
250.
250? I was going to start going higher or lower soon. Wrong.
1,500.
1,500? Right, so now we're lower. 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 It's going to get less and less impressive.
5.
5 higher. Just between 150 and 200. Now there's one part he's holding on his hand.
Wow.
Lower.
55.
Very close. 157. 157 parts are in that cake.
So what would be the sort of the average sort of that we would do on a, whenever we're doing a build?
Yeah, so because we've got a few exceptionally large parts, what we would regard large parts, typically a build that size, we should actually have about 400 or 500 parts in there. So for that same 40 hour, we can, given the component, we have snuck up to sort of 2,000 to 2,500 parts. So again, at a 40 hour rate, we're starting to get just mere minutes per part. So the production rate is, and that's what this machine lives for. It's a production manufacturing machine. We're not talking prototyping here. We can do it, and we do it, don't get me wrong, but it's whole goal of mine is production. So what we have to do as part of this process is we take the parts out, we have to dust off the powder. Any powder that doesn't get made solid, so with the laser, we put that back into this machine. So this room's called the MQC, Material Quality Centre. The material gets recycled back through, and we can reuse the powder. So we've got some efficiency gains here as well. And we can do pretty much whatever geometries, as long as they're physically separated by about 3 millimetres, then we can do, and they can be whatever rotation. If we've got a part like this,
300 and even 300 in one block.
correct, we often will have 15, 16, 17 customers in one building. So you'll actually have a hutching in those.
Just as long as they're not touching, you can have a whole lot of different parts in one build.
Yeah, like you'll see these little coloured balls here. We've actually got geometry inside it. because as long as it's separated, we can print that as well. So you can have encapsulated geometries as well. And you'll also notice there's different colours and all that. We have a few post-processing things where we increase the surface finish, increase the mechanical properties with dotting and colouring and smoothing, and there's a post-process room out the back. So there's other options that we can do down the track as well. So yeah, really good manufacturing. So this one exists for small and detail. This process exists for manufacturing.
We're going to do sort of the reveal on here, and I just sort of want to reiterate that this is a pretty proud moment for us because we've kind of kept this a secret. Well, not a secret, but we haven't done any launch, and we haven't really let anybody know. And we have had customers that have heard that we've got this, and that's what's been keeping this machine busy. So you can probably hear that it is running. So again, feel free to come in and take a look because it's a pretty cool bit of kit. With the other one, you can look through the little screen and you can't really see a lot, but with this one you can actually sort of see a laser and you can see it all working. So I don't know how this is going to go when I take this down. So yeah, I'll hand back over to Derek to sort of run you through what this technology is and where this comes into play and what it can do.
So what we've got here is SLA. So this is a stereolithography, is the name of this technology. We've got similarities with the first machine, the SLA. So both of these are a laser-based machine. This one's running a powder that you've seen. What happens in this one is we've actually got a big resin bath in there. So there's a laser lives up to the head. It's coming down, and where that laser basically hits the resin, it turns it from liquid resin and solidifies it. And again, it does that through a whole cross section. It screeds a new layer of resin. Table drops. We're back to that cross section concept again, and yeah, the part then builds up. So unlike the first one, so we've got a build chamber down there of 463, 83, 30, and you saw sort of the size of the cube. This one here, we've got 750 by 650 by 550. So this is a large, in 3D printing world, this is a very large capacity machine. So this is the biggest in the country. We talk about manufacturing. This is obviously very good. So all these parts that are in this thing here, so SLA, and SLA, by the way, has very little to do with the stereolithography part. We're actually not quite sure how they come up with that, but the marketing department, I think, was having a bit of an off day. However, everything that's in here was built on this machine. So very, very good at prototyping, and that's where it comes from. One thing that this machine does really, really well, one of the materials that we've got available is an investment casting one. So that means we can print a material, send it to a metal foundry. So, and this clear part here, for instance, is one of them. That goes to the metal foundry. That then gets a process done to it where they cover it in a slurry, as they call it. They burn that part out, then cast the metal in, so that shape. So we'll print it in polymer, plastic, and then they will turn that into metal. So it's no molds, no tools, no nothing. We're back to all those advantages that we talked about before about flexibilities and what have you. So fantastic machine, big capacity, really nice surface finish, and yeah, so it's absolute state of the art. So second question, so we say state of the art. This technology, SLA, and it's sort of the backbone of the 3D printing industry. What year was the first patent for SLA technology? No, Jim, you cannot answer. 53. Wrong.
71.
Wrong. Last year. Wrong. 80s, from the 80s. No.
82.
Right, honesty session. Who said 86?
Gareth, what's next?
What's next? Yeah. Funnily enough, we have got some, we have got some things in the pipeline. but that'll be maybe the next BA5. No, yeah, we've always got something cooking, but yeah.
Favourite thing you've made?
We'll talk about you think about the user and where it's gone. There's some work that we're doing with New Zealand Artificial Intelligence Service, or CITIC's name. So you get the files through, and you get some of them, and you just start to see where it's going and what it's doing. So it's cool to do various car and all that sort of stuff, and we're doing some really nice work with some motorsport stuff. That's cool. That's cool and exciting and all that. But yeah, so yeah, some of those other ones are pretty cool.
Derek, what about the unique one that we didn't realise that it did? TV.
Oh yeah. So we're sitting at home one night and just watching the TV. Next thing, TV ad comes up. Sort of sit there and look at it. Familiar. And so jumped on the phone, had a look at the files, and sure enough, so the 2 degrees. And so the restarting candle head.
Oh, yeah.
Everyone knows what I'm talking about? That got printed out of that machine. So they painted it up, and what threw me was that they put glasses on it. So it was the classic Superman disguise. And yeah, as soon as I took the glasses off, and I went back and had a look at the file, yeah, so we had restarting scanned head come through here. And used in the air.
And at the time we were thinking, who wants to be faster?
What we've got here is, 3D, as I said, we've got to have 3D files that go into the machine. You can either sit there and CAD them up, you can download them, or you can, this is another way of creating them. So we use this basically 3 ways. First way is for geometry capture and reverse engineering, so literally scanning an object, taking that geometry, and we can either scale it up or incorporate it into other things or what have you. So that's one. Second is for QA purposes, so when we print parts, we can scan them, and then we can do comparison back to the original CAD file and actually see how far off we are or aren't. And just, yeah, it's just a quality check. And the third is it's a very good condition monitoring tool as well. So if you've got industry plant or what have you, that especially wear faces or something, you want to just keep a track on, and it's a very hard face to measure, so you can't just get your tape measure in there and measure it. So it's you can imagine if you've got product or something coming down the face and it's wearing it away over time, you can scan the surface, and you can do periodic comparisons and just see how things are going. So measures to 0.02 of a millimetre. And the third question coming up, and this is the last question for the night. So it goes through, and basically you've got these 2 cameras on here. We've got these dots. It's a referencing system. So every second it's taking a series of measurements, and so then it knows where everything is. How many measurements per second does the scanner make?
24.
24?
I like that.
Higher?
Whoever said that knows about video cameras.
We're higher than 1,000?
500,000.
500,000? Higher?
2 million.
2.4 million.
Lower. Don't take it. Down near it, it's over 1 mil.
1.2.
Close.
1.4. 1.3.
1.3 million. 1.3 measurements per second is what this machine's doing. So, yeah, so that just means that the surfaces that you get off it, very, very high quality, very, very fast at scanning, and just a very important part of our workflow here as well. So,
We've always wanted our own products, and I think that we will get there. Like at the moment, our focus is on getting this out to New Zealand. We just want to focus on the New Zealand market, what we can do down here in Invercargill, and get this really, really cranking. That's our whole focus.
Huge opportunity.
Yeah, it's like the market is like we've got these machines, running flat out, but we haven't really scratched the surface, So we just really want to focus on, and then I think we might try and bring some products of our own stuff. But there's also other technologies that we haven't got that we know that would be a really nice fit, but it's trying to get that across the line and it's working out next steps and stuff. Yeah, so.
Imagine that BA5 in 25 years.
Yeah.
We're like the size of TV.
I just want to finish by saying thank you all for coming. It's been it's quite as far as BA5s go. I think this is, the numbers registered for this event have been absolutely fantastic. So, and we just really appreciate the support. So, yeah, thanks very much.
Thank you.